right, how close to 6 do we have to take x so that 5x minus 3 is within 0.01 units of 27? Talked about this on the first one, right? How close is the delta idea? It's that distance. So for starters, we set up absolute value. We start with our x's. We're going to take x minus, in this case it says how close to 6 do we have to take x. So it's x minus 6. Got that absolute value. That's going to be less than the delta idea we're looking for. And ultimately how we're going to find that delta idea, we're going to set up another absolute value over here that compares the function and the limit concepts. You take the absolute value over here. Got your expression of 5x minus 3. That's basically representing my function idea from my definition. I'm subtracting. Well, it says we're getting within 0.01 units of 27. So 0.01 units is the distance. 27 is what we're getting closer to with that distance. So we subtract 27. That is all less than that distance of 0.01, which is representing the epsilon idea here from that definition. So the key is getting the setup right. Once you get the setup right, we work off of this part. We do some simplifying, some factoring. Ultimately, in the end, we get an answer we can compare back for our delta right here. So if I collect like terms, get the absolute value of 5x minus 30. All of that less than 0.01. I notice the greatest common factor of 5, which I can take out. 5 pops out. You got the absolute value of x minus 6 left, less than that 0.01. I'm trying to get the absolute value of x minus 6 out of this, so we can see that right here. If I divide both sides by 5, got absolute value of x minus 6 less than 0.01 all over 5. So that absolute value is solved for in this inequality. What we're comparing that absolute value to over here is 0.01 over 5. We make the connection back to this part. That must be our delta. So we slap a little therefore statement on there and we say let delta equal the 0.01 over 5 that we found. There's your answer. All right, on this one we're looking to see how close to 3 we have to take x so that x squared is within 0.01 units of 9. We've got our setup down now where we start with the absolute value of x. We subtract. Well, here we're talking about how close to 3 we have to get, so we'll subtract 3. That'll be less than the delta we're looking for. As we set up the rest of this, we've got the absolute value of your function minus the limit idea. So the function here, expression is x squared minus, we're getting within 0.01 units of 9, so we're subtracting 9 because that distance of 0.01, that is my epsilon idea. So we focus in, make sure we got the setup down. If we got the setup down, we concentrate on this part of it. We try to do some factoring. Now the previous two examples we did, we had a greatest common factor, right? Here you've got a difference of 2 squares. So let's factor it as a difference of 2 squares. I would have x minus 3, I would have x plus 3. All of that less than 0.01. Now you got a couple of expressions here that have x in there, and you got to look at where you're going. You want to get the absolute value of x minus 3 by itself. So you're going to divide this x plus 3 over. Absolute value of x minus 3 less than 0.01 all over absolute value of x plus 3. And normally at this point, we'd say, okay, absolute value x minus 3 is solved for. If you look at how these inequalities are set up and we do some comparing, delta has to be this guy. But on the previous two problems, this part was a nice, clean numerical answer. But now this part has an x in it, which is not acceptable because it doesn't actually give us a distance still. So what we do is off to the side. We go back to how we were playing with limits once upon a time, and we consider an interval to play with here. What we're going to do is we're going to consider an interval that surrounds this number 3 we're trying to get close to. So whatever the x is. The interval we're going to select is going to be 2 to 4 because 2 and 4 are each 1 unit away from 3. Right? Think back to how we played with limits before. When we explored them with our calculators, we just crunched in some numbers. We were always starting at a number that was 1 unit away from the number we were getting closer to. So you consider that interval. And if you consider that interval, we're going to let x equal the start of that interval, 2. We're going to let x equal the end of that interval, 4. And we're going to take those numbers and we're going to plug in to this expression we got over here. So if you plug in, now let's see, you've got 0.01 over the absolute value of 2 plus 3. And when x is 4, you got 0.01 over the absolute value of 4 plus 3. Calculate that out. You got 0.01 over absolute value of 5, which is 5. And down here we got 0.01 over absolute value of 7, so 7. So you get 2 answers back. Well, it appears that way. We can't have 2 answers. We can only have 1. We're looking for 1 distance that we have to get closer to 3 with. And what we do out of these 2 answers is we select the answer that is the smallest distance. Right? That allows us to get the closest. So which of these is the smallest? Yep, 0.01 over 7. This is the smallest. So I've kind of run out of room here. Let me see if I can squeeze this in. Therefore, let delta equal 0.01 over 7. So what you take away from this problem as you compare back to the previous 2 we've done, setup is the same. Solving is very much the same. It's just when you got to your answer had an x in it. Right? We had an x over here. So because you have an x over here, that's when you have to go over and do this consideration.